Hello and welcome. In this video, I'm going to talk to you about Development Master Data or DMD. What is DMD? DMD is called Development Master Data. It is called by different name in different organizations. But this is a tool to capture development data for any master plan development, large scale master plan development. The idea is to capture data in a clean and presentable format. Also, we must remember that this forms the basis for the financial model or the feasibility of the large scale master plan development. So this must be organized in a very, very clear and concise manner. So let's get started. Okay, so let's look at this master plan. This master plan is rather a small master plan, and it looks like a very small master plan. So when we say DMD, Development Master Data, what do we mean by Development Master Data? How does this look like? So Development Master Data captures the development data of individual plots, each and every plot in the master plan. Usually I organize the data this way: serial number, plot ID. You might have sectors, asset class, residential, product villa. You might have product quality grouping in your organization depending on the positioning and the quality. This is just the unit count, land area, gross floor area on this particular plot, GFA per unit. So this is just GFA divided by the unit count. Parking area, we will come back to parking area. The built-up area is basically the sum of GFA and the parking area. Built-up area per unit, net saleable area or gross floor area, although they are a bit different, but for time being, we will use them interchangeably for this exercise. NSA per unit, and then you have floor area ratio, which is basically GFA divided by your land area. So there are some other ratios here, which is NSA by GFA and NSA by BUA. These are also efficiency ratios. When we calculate NSA, we will come back to efficiency. What is efficiency? So efficiency is basically in development, we mean that NSA divided by GFA. But there are a few other efficiencies ratios which should be kept in mind while designing a building. We might like to capture some other data of this development: height, number of stories, which phase this particular plot belongs to. We might, divide this development into various phases. The start date, we might have another column here, probably say launch date. The launch date might be much earlier, so I want to launch the product at least 1 year before I start the construction. Brand name, we might have different brand name of the building. Each of these buildings will be branded, probably not RC branded, means not the branded residence, but like white label kind of brand. Also, we need to capture the views, so there might be different views: park view, road view. Rather than calling road view, I call it urban view. There might be some other different kind of views here and there. I do not see any water. I do not see any other, premium views here. Also, I would like to capture development strategy. I want to capture the status of this project, this particular plot. It is under planning or planned or under construction, delivered, and some other information, whatever I want to capture. The issue arises, when we get this data from the architects or the master planners, we get it a bit in a different format, and they capture data differently because they think differently. Let's look at this particular, I will hide this for time being. So look at this plot. In the master plan, this is the plot I'm talking about. There might be other plot as well, which will have, mixed use on this particular plot. But let's look at this particular plot, and this is the plot which belongs to sector B. So what are sectors? Sectors can be your Like this is one sector, probably this is another sector, this is another sector. This might be divided into few sectors or communities or cluster, whatever call it. This is the way most likely architects will capture the data. So they will capture which sector it belongs to, asset class, product type, product quality probably. If you tell them, they will capture. If you have a brief, unit count as well, definitely land area, and the GFA. This is a bit of problem. So they like to capture the data in this way, in column. But this becomes a bit of issue for financial modeling, as well as doing development analysis, creating dashboard for the developments, because they are in columns. And there might be other plots which will have another uses, sports. So all the data will come in columns and get populated here. This creates a bit of problem. I want to filter, I want to see unit count, I want by use, land use. Either the solution is that we call it mixed used, or what I call it, unpivot this data. So if you look at this, I would like to get the data in this format. So I will create 3 rows because there is 3 uses on this particular plot. Residential, community, and retail. Product type, just call apartment. I think we have put apartment on this particular plot. Yeah, apartment. And community, retail, product quality A. Now these are the GFA. I have just got this transposed it here. Now I want to find the land area on the basis of prorated on the basis of GFA. So what I'll do, I will just go here and get the total of this and find the ratio of these GFAs here. And this is the ratio. So the land area prorated on the basis of GFA would be, where is my land area? My land area is here, which is 1500. And so this is my land area. And I will populate it here. And I don't need this any longer. So if you look at the data, this versus this, my personal preference is to capture data this way rather than capturing in this way. And we will see why it makes more sense to have the data in rows rather than in column. So if I go back to my DMD, these are the three uses on this particular plot, which I have captured in rows, which I just explained. Okay, so let's do the parking calculation. For doing parking calculation, we need to define the parking ratio for each of the asset class or the product type, and we need to know the average mix of villas versus apartment, 1 bedroom, 2 bedroom, studio, what kind of parking ratio they have. But for time being, for sake of simplicity, we say each 100 square meter we provide 2 parking. So we just do it this way and say each parking space takes 40 square meter including ramp and circulation. This gives me total parking area. Does it make sense? 2 parking per 100 square meter GFA. It looks a bit odd actually for like this use. So you have so much GFA and you have so much parking area. But since we have not defined specifically for each asset class, each product type, we are applying a generic rule that each 100 square meter of GFA will need 2 parking. It's a bit very high for residential, but if you do 1, you will see that for offices this looks a bit low, very low in fact. But that's okay. Now built up area is the sum of parking area and GFA. Now NSA is basically a function of your efficiency, design efficiency. So what we can do, we can just define the efficiency of each of the uses. So we go there and take all the product type, unique of this, and we have these one. Now we just define the efficiency. So let's say villas is 95%, sports center is 80%, grade office is 80%, club is say 70%, hospitality is 65%, apartment is 80%, community center is 65%, retail is maybe 70 because they are small. It is interessant. School is maybe 65. Now if you go back to DMD and just let's find out the NSA, so we can do is equal to VLOOKUP here, and then just look up this on this table. So this will give me the efficiency of that particular product type. Now I need to multiply this efficiency with my gross floor area, and this gives my net level area. So all of this data is populated now. I do not need to capture any other data for time being. Let's go back to, okay, the other thing which I would like to highlight, usually I do sum on or the subtotal on the top, because in a large scale master plan we will have thousands and thousands of these rows of the data. I do not want to go down and look at the sum, rather I would do subtotal here. So even if I filter, like I want to see all the residential, I can just do and see, okay, what is the land area, what is the GFA, what is the unit count of residential assets, and so on. And this makes life easy also for, if you remember, this mixed use plot, because now I correctly capture residential assets. When we organize the data in this format, life becomes simple when I want to do dashboards for my development. Just for example, like I want to create a table for my, or a chart for my GFA by asset class. I can just like, this asset class and the GFA. So I do sum if of these ones, okay, and so my criteria, time being I'm just putting any criteria, and let's look at the sum range, which is my GFA. So this is 0 because I just need to link the criteria here, and now here you go. So this is your total GFA, and this, I want to create a chart. I can create a pie chart very quickly here, which will give me my GFA breakdown. So this, when you organize the data in this kind of template, lives become very simple for development analysis. Very easily I can, even I need to filter, okay, what are the plots, what is the quantum of plots which are under development, so, or what are the views which are develop and sell. So I can just go and filter develop and sell, and I can see all the data on the top. And similarly, any other variables, I can just filter and see the data or the output on the top. And also I can very quickly create these kind of charts for any development parameter. I can just come here. If somebody wants to see, okay, what is the efficiency, what is the, what is the status, what is the breakdown of under construction, under development, delivered assets, we can very quickly do the sum ifs. Also, when we do financial model based on this development data, it will be very easy to filter the financial KPIs and create a very agile financial model if you organize your development data in this template.